In this lecture, we're going to talk about temperature and thermometers. In everyday language, many of us use the terms temperature and heat interchangeably. But in physics, these two terms have very different meanings. So for instance, think about this. When you touch a piece of metal and a piece of wood both resting in front of you, which feels warmer? When do you feel warmer, when the air around you is 90 degrees Fahrenheit and dry, or when it's 90 degrees Fahrenheit and very humid? In both cases, the temperature of what you are feeling is the same. Why then are you feeling a difference? In this unit, we will learn about temperature, heat, and the law of thermodynamics that relate heat, mechanical work, and other forms of energy. So let's talk about temperature. Here are some definitions of temperature. It's a measure of the warmth or coldness of an object or substance with reference to some standard value. Any of various standardized numerical measurements of this ability, such as Kelvin, Fahrenheit, and Celsius scale. It's a measure of the ability of a substance, or more generally of any physical system, to transfer energy to another physical system. It's a measure of the average kinetic energy of the particles in a sample of matter, expressed in terms of units or degrees, designated on a standard scale. We will consider each of these definitions in this unit. To measure temperature of a substance, we need 1. A measuring device, such as a thermometer, that changes visibly and is calibrated to a scale. Thermometers relate the change in a physical property of a substance to temperature. So some examples are the change of volume of a gas or liquid, the change in the length of a metal strip or a piece of wire, the light or infrared radiation emitted by an object. And number 2, to bring the thermometer into contact with the substance. So when the thermometer has settled on a value, we can say that the thermometer and the substance are in thermal equilibrium. So here are some pictures. Here we have a liquid thermometer. Here we have a thermometer that's run by a bimetallic strip. A bimetallic strip is two pieces of metal that are secured together. One of the metals will expand or contract at a faster rate than another, and that causes a bending effect of the metal. The other is a gas thermometer, which is a manometer. Recall that temperature can be defined as a measure of the warmth or coldness of an object or substance with reference to some standardized numerical measures or scales. There are 3 common scales that we use: Fahrenheit, which is mainly used in the United States, Celsius, which is used by most of the world, and Kelvin, which is used in physical science, such as astronomy. This is also known as the absolute temperature scale. So here are the 3 temperature scales. For Kelvin and Celsius, there's only a 273 degree difference between the two. So when you have a boiling point of 100 degrees Celsius, it's 373 Kelvin. When you have a freezing point of 0 degrees Celsius, it's 273 Kelvin. For Fahrenheit, there's actually a 180 degree Fahrenheit difference between freezing and boiling. Here you can see at the bottom that at absolute 0, Kelvin is 0. For the Celsius scale, it's negative 273 degrees Celsius. And for Fahrenheit, it's negative 460 degrees Fahrenheit. So you can see there's a relationship between all 3 scales. So in order to go from Celsius to Fahrenheit or Fahrenheit to Celsius, you use the following formulas. To calculate the Fahrenheit temperature, you multiply the Celsius temperature by 1.8 and add 32 degrees. If you have a Fahrenheit temperature and you want Celsius, you subtract 32 and then divide by the 1.8. In order to go from Celsius to Kelvin and Kelvin to Celsius, you add 273.16 degrees to Celsius scale, and that will give you the Kelvin temperature. or you subtract 273.16 Kelvin, and that will give you the temperature in Celsius. Which temperature scale does not have negative values? Hopefully you pick C, which is Kelvin. Water freezes at 32 degrees Fahrenheit. What temperature would this be on the Celsius scale? The correct answer is B, 0 degrees. Water boils at 100 degrees Celsius. What temperature would this be on the Fahrenheit scale? The correct answer is D, 212 degrees. Room temperature is often taken to be 68 degrees Fahrenheit. What would this be on the Celsius scale? If you need to pause the video, go ahead and do so now. Okay, so let's take a look. If you stick the number 68 degrees into this formula, you should end up with D, 20 degrees Celsius. The coldest temperature recorded on Earth was negative 89.2 degrees Celsius at the Soviet Vostok station in Antarctica on July 21st, 1983. What would a Fahrenheit temperature have measured? If you need more time, go ahead and pause the video. Substituting in the negative 89.2 degrees into the formula, you end up with a temperature of negative 128.6 degrees Fahrenheit. The coldest temperature recorded on the Earth was negative 89.2 degrees Celsius. Now, what would the Kelvin temperature be? We're going to add 273 degrees to that number, and we end up with 183.8 Kelvin. In the next video, we'll talk about thermal expansion.